You see something interesting? Let's entertain this idea. Maybe it's nothing. Maybe it leads to many more fruitful things. Coherent units, yes, yes. That video that Thad had was very impactful. That's often why I refer to it. Okay. So coherent units, we have force. F equals ma. Force equals mass times acceleration. Energy equals force times distance. Power equals energy divided by time. From our friends at Wikipedia. And again, there's some synthesis in the article. Feel free to disagree. When you do the calculations, it seems to work out. So, and again, this wasn't my work. Thad had just highlighted this. Like, this is probably important. Maybe more folks should pay attention to this. So, some may have heard this saying: once you have F equals ma, we can derive all of physics. All the readers should have their doubts about any all-encompassing claim. The general notion is a powerful one. If we are searching for the underlying machine code and ultimately the rule for our universe, we must latch onto some physical thing. Early work on the physics project had postulated that we may interpret energy as a count of edges in some hypergraph. This intuition still seems as the best method of going about this, as we have the ability to count. Let's take a moment to break down the reason why we're discussing this topic. Okay, so F equals ma. Let's make it just a little bit bigger. There we go. All right. Force equals mass. I should probably edit. Undo. What did I do? I don't know what I did. Half. Okay. I'm not going to mess with that. Sorry. All right. So F equals ma. Take, for example, a clothes dryer. Barring any thermodynamics and just focusing on the spinning drum, one could imagine giving it a nudge, causing it to accelerate just a bit. We have thus applied a force and caused its mass to accelerate. And again, maybe this isn't the best way because there's other ways to quantify this. Is basically a basic example. Energy equals force times distance. Now, a casual nudge to the drum of our clothes dryer will not do too much, as we need it to cycle and thus rotate a distance. Therefore, require a force great enough for our drum to rotate, say, a full revolution. All right. So now you have a force, and then you're multiplying that force over a distance. Oh, that's energy. Okay. Now we have power equals energy divided by time. We actually would like our clothes dryer, again, neglecting the thermodynamic component, we would like our clothes to dry, so we would like it to spin more than a single revolution. So we require that energy to continue over a period of time. The period of energy that we need to dry our clothes will correspond to the amount of power we require. Okay? This exercise was to prime one's notion of the importance of the relationships between our dimensions of measure, represented by the corresponding units. In particular, energy is a prime example of how simply dividing or multiply by time or length will generate additional units. So the expression. Now we're just using Planck units here. So we got Planck energy divided by Planck time. So as we saw for our zeta, that gives us the Planck power. Cool. Energy times time gives us the units of joule seconds, aka action, which is more basically about equivalent to the elementary unit of action, h bar. When you've got energy divided by a length, it's going to give you the unit of newtons or force. And then when you have energy times length, you're going to get joule meters, which, again, at least according to Wolfram alpha, is bending stiffness, or the product of the elementary unit of action times the speed of light. I did not know that was a thing until I went through and did this. So it seems pretty cool. I mean, it's just what it comes out to be. So the methodology behind this is to identify features of physics as we know it to verify the underlying rule of the world. We should be able to count edges to determine the associated energy and explore our multi-way system to identify other standard phenomena. One such method, as inspired by project mentors Hatem and Nick, would be to simulate the formation of a minimal black hole. So it'll likely require extremely high resolution mapping of all the underlying edges within the causal graph. That may or may not be feasible at this time. The idea is that if we know a physical limit via general relativity and had the ability to simulate within our hypergraph landscape, we should be able to nail down the elementary energy via counting edges. So basically just taking the whole thought process within the Wolfram physics project and basically just extending it. It'd be like, all right, what if we assume this was true? That's one of the things I learned from that.